Now we're going to define the polynomial of Chebychev or Chebychev polynomials. Okay, this is a great Russian mathematician, so it's written different ways, but it doesn't matter. So it's Chebychev, Chebychev, Chebychev. It depends on the pronunciation, but the most important thing is that these polynomials, and we're going to see why they are polynomials, are defined by the cosine of the n arc cosine of x. So Tn of x is the cosine of n times arc cosine of x. The first thing that we need to do is, what's the domain of definition here? So if you have done pre-calc and you know that you have done the inverse functions, clearly we see that the domain is going to be minus 1, 1. Okay, remember the restriction of the arc cosine or the cosine to get the arc cosine. Okay, anyways, let's see and try to find some simple and first few values of these polynomials. The first thing that we can do is when n is 0, so we get t0 of x is the cosine of 0 times the arc cosine is 0. So the cosine of 0 is 1. So our first element of these polynomials is 1. Now let's find 1, the polynomial of order 1, or the first one. This is order 0. So we have the cosine of arc cosine of x. Since x is in minus 1, 1, and these two functions are the inverse of each other, we get x here. So this second polynomial, or the polynomial of order 1, is x. Now we're going to see what we get when we have n equal 2. So we have the cosine of 2 arc cosine of x. Here we have to do some work to get the result by remembering that the cosine of 2x is 2 cosine squared of x minus 1. Okay, so doing so, we get this one, the cosine 2 cosine squared of arc cosine of x minus 1. And we know this one here, from here, this is just x. So we have 2x squared minus 1. Therefore, the order 2 polynomial is 2 cosine squared minus 1. 2x squared minus 1. And the first one is x. And the 0th one is just a constant, polynomial 1. Now let's do one more. Let's compute the third order, or the polynomial of order 3. So here we use the definition, the cosine of 3 arc cosine of x. We're going to do some work to get this one. Okay, let's split this 3 into 1 and 2. So we get cosine of arc cosine of x plus 2 arc cosine of x. And using the sum of the angle for the cosine, we get cosine of arc cosine of x times the cosine of 2 arc cosine of x minus sine of arc cosine of x times the sine of 2 arc cosine of x. Here, we know this one here. From previous work, we know this one too. But we don't know this too. We don't know the sine of the arc cosine. But we know one thing here. Sine of 2x, we know that. So we know that the sine of 2x is 2 sine x times cosine x. We will use it here. So therefore we get, here I get x times 2x squared minus 1 minus, here I'm going to have the sine of the arc cosine of x times 2 sine x, sine arc cosine of x times cosine of the arc cosine of x, using this one here. Okay, so I get x times 2x squared minus 2 sine squared. 2 sine squared is 1 minus arc cosine of the arc cosine squared. Okay, I don't know if I can do this one more time. Okay, let's do it. So it's gonna give me the cosine of the arc cosine squared times, it's not the square, it's here, the cosine of the arc cosine of x. Okay, and I get x times 2x squared minus 1 minus 2 times 1 minus x squared times x. So when I simplify, I'll get, let's do this simplification here. So I get 2x cubed minus x minus 2x plus 2x cubed. So we get 4x cubed minus 3x. So this is my polynomial of degree 3, okay? So T3 of x is 4x cubed minus 3x. Okay, so we get the first few polynomials of the Chebychev, okay, or Chebychev. And if you keep working, the matters will get complicated. But we can have a, I don't know if I have it here with me. We can prove that in general we have the polynomial of order n plus 1 is given by 2x tnx minus tn minus 1x. So this is the polynomial of order n plus 1 is related to the polynomials of order n and n minus 1. And this recursive relation, let us find all these values.